Thank you very much for the invitation. I hope I don't hold you too long from the lunch or the transport training, but given the fact that I am in between you and the lunch, I thought I would start with a quote from Ernest Hemingway. So do take that on. What I'd like to do is really to talk a little bit about ELIXIR, which is another of the S3 research infrastructures, and we heard two other examples this morning of the BBMRI Eric from Peter and just from Antonius on Instruct. ELIXIR has been on the roadmap since 2006, and so we are perhaps a little bit more mature in the infrastructure sense. But so what is then the problem we are trying to solve with these distributed European research infrastructures? And I think this map from ETH, which is from omicsmaps.org, I think is a very good illustration. It's probably out of date already, but it's it's the self-reported number of high-throughput sequencing machines at different genomics facilities in Europe. And I think what it shows very convincingly is that data generation, as we know in biology, isn't confined to a single center. It is not the same as physics or astronomy, where you have a big data producing machine that you then need to ship the data out to the community. We really have a very distributed data management problem, where data is generated at literally thousands of institutes across Europe and across the world. And actually what we want to do is to compare the data that we generate with data generated at other institutes. And this is where we have the problem on standards, on data shipping, and on an infrastructure that actually really scales to attack this problem. And I'd like to show and give you a flavor of how we try to think about solutions to this within ELIXIR. I think the other part of this, and we've mentioned this a couple of times this morning, is of course how do we then manage to secure access and the governance of dealing with human data in the translational space. And in a distributed system where this data is collected by a number of different institutes in different jurisdictions, then this becomes largely a provenance issue, but also a mutual recognition scheme. And Peter talked about things like a code of conduct, i.e. how do you know that access from one institute and the management of data at another institute in another country complies with what you have promised patients in your study at your institute. And I think that the third area that we really like to tackle is really the long-term sustainability and reusability of data that comes out of these open data mandates from national and European funders. I mean, Mike said it this morning, we don't really need to talk about open data. It's actually prescribed for very many of the research projects that we are participating in. There is a mandate from the funders that we need to make the data reusable for others. Now that does require some thinking and a bit of infrastructure, and I'd like to share with you some of our thoughts of how we can address this. So ELIXIR right now is, so we're an intergovernmental organization, and we are set up as an independent unit within the European Molecular Biology Lab, which is an intergovernmental organization registered with the UN, and so we can operate transnationally. Currently we have 20 countries plus EMBL as our members, and one observer state, Greece, which we hope soon will join. And then we're talking with a number of other European countries and also outside Europe. So I think the take-home message is that we really reach out to most of the research community in Europe through our national centers. And this concept of national centers is really important in ELIXIR. So we are a distributed organization. We're built around the concept of a national node. These are really the backbone of what we do. The coordinating entity, which I lead in Hingston, is a small program management office. The action is out in the countries. And so these nodes are funded nationally. And I think that's really, really important for two reasons. And one reason is, of course, that then that funding aligns with the national research priorities. And so here is an example of the Swiss node, which have a very long-standing national network, active in most areas. But actually one area where they're not very active is marine research. whereas, for instance, our node in Norway is very, very active in the marine sciences and leads ELIXIR's programs on marine sciences. And I guess it's not surprising that it's a very important research area with fish farming and other sort of aquaculture industries in Norway. And it's not surprising that Switzerland takes a rather sort of remote interest in marine sciences. And the other thing that our national nodes provide, and I think this really is important when it comes to sustainability, is that they provide a national framework for long-term resource management. So most of research data and most of research activities in Europe are funded nationally. And of course, the national initiatives are really the core of long-term sustainability. We saw a good example from Jan Willem how this has been managed in the Netherlands. And if we, as ELIXIR, can drive the collaborative definition of standards that are implemented in these national resources, then I think we have an inherently much more robust, scalable and sustainable architecture for data management in Europe. And so that's really what we're trying to do then, is to support our nodes to provide that collaborative definition of standards, but also to build up national organizations that can be supported through national roadmaps. And I think that's one of our actually key success stories, is that we now have these national nodes established in 21 countries in Europe, and real interest from some of the remaining countries like Austria, where they are working very hard to establish a national node. And the SIB, the Swiss Institute of Bioinformatics, I really think is an archetype here, although you see now many countries having operations that have been going on for 10+ years. So we are more than a network, we are an infrastructure, and I think that the hallmark there is that we actually drive a joint technical program. So we have a set of legal agreements that allow us to execute technical studies across the nodes with the different people, but so we can operate as a virtual organization. But I think the key here is that we can drive an internal technical program that glues together activities in the different nodes. It's not a large budget, it's not a large program in terms of funding. It's easily dwarfed by things like ELIXIR, but it actually provides that little glue funding that helps, for instance, in this case, Belgium, EBI, Spain, Switzerland, Netherlands, Finland, and Sweden to come together around a data access and data findability standard. So that I think is really important and something we're very proud of having achieved here in the first place. So just as to round off what we are, it's about 180 institutes involved in ELIXIR across the member states. That translates into over 600 people on our weekly update mailing list, people involved in our different projects and activities. This is about half of the crowd in our annual meeting in Rome. And it's a message to, I guess, the US President, we did fill the whole square. We have 11 of these internal technical projects currently in operation, so we do try actively to glue together the nodes. We like to make this published, and we've launched what we call it's a channel on Faculty 1000 Research, but it's essentially an outlet where we help to publish in an open access, open peer review format research data infrastructure reports and papers. And so it's sometimes very difficult to publish in some of the community journals like bioinformatics and so on, to publish methods papers on research infrastructure. And so we really like to have the developments done within the ELIXIR out in the peer-reviewed literature for others to build on, and so we've launched this. And we have about 10 papers in the channel. There are a few more in the pipelines, and I think that's been very successful. One of the nice features, I think, is that you see the referee reports on the papers, and actually the comment and the dialogue between the authors and the referee reports, which I think works incredibly well when it comes to infrastructure and standards. It's not necessarily the best way for research results, but for developing common standards, I think this is very effective. We're also pulling together the training program. I won't say much about our training program, but we do have a coordinator group with training leads from all our national nodes, and we run a very large training program, so over 200 live training events in our training portal. And of course, this is really, training is really key to have the infrastructure established and getting people used to the various services. And we also run an SME program where we partnered with national and local biocatalysts and bioinnovators. So far we have over 200 companies attending our SME events. We have one here in Barcelona in about 3 weeks' time, where we partnered with the Spanish node, the Barcelona BioCat Innovator Hub, and local companies. I think there's about 100 people and 50 companies registered, so that's an example of how we really try to build them local innovation environments. It shouldn't go through the head office, it really is based on our national nodes. So that's a little bit background of ELIXIR. So what I thought I would do in the remainder of the talk is give you a few examples of how we're implementing this concept of fair data across Europe, and what the type of services that we are trying to pull together from our national nodes. So I don't think I need to introduce FAIR, we've talked a lot about it, but it's easy to say findable, accessible, interoperable, and reusable. Well, it's not that easy to say interoperable, I guess, but the question is, how do you back this up with a service stack that makes standards the default and actually makes it possible to reuse research data over a long period of time? And so we've addressed this in a couple of different ways. One of them is really looking at the core molecular archives, so the reference databases. And we've called this what we call core data resources, to try to identify a set of data resources, not tools, not services, but data resources that really is of the fundamental importance to the life science community, and where we really need to focus the long-term preservation. So these are the gem banks, the ENAs, the nucleotide archives, the UniProts, and so on of this world. And so we think they really are providing a high level of scientific quality and service. And so the way we've gone about this is really that trying to define this through a collective process. So each of our ELIXIR nodes, so for instance ELIXIR Luxembourg is here, and you see some of their offerings around the data catalog. That's brought together in sort of the collective ELIXIR services, and that's driven through national processes. From these, we're in the midst of our first selection of a collective definition of what really we think are the most important data resources that where we focus our science policy activities. I'll come back to that, but also these serve then as authority identifiers. So the way to identify a protein is through UniProt, and so they have a normative value in the life science community. And you do that through a sort of a basket of different indicators, so essentially putting some guidance on how you should be driving and building a long-term resource. These are things, of course, like the scientific focus and the quality, but also aspects such as governance. So if you aspire to be an infrastructure, you need to have a mechanism for scientific oversight, but also user input. It's not a research project driven by the curiosity of a single PI. It is a community service, and therefore it needs to be governed as a community service. And importantly, we look at things like impact. And so we've mapped these to the sort of FAIR indicators, but essentially what we'd like to say is that what we define as core resources is FAIR plus impact, and really trying to define how you express the value of these research infrastructure assets to the community, but also to the funders. This has actually been generating quite a bit of interest. So we published this in the paper. It's very highly accessed. Within a year we have over 16,000 views. But actually there has been a lot of interest both from NIH and NSF, who are going through a very similar process now for the NIH funded databases. And the Human Frontiers of Science program called before Christmas a meeting in Strasbourg, which is now followed up with a high-level funders, of global science funders meeting, where we're trying to build a global coalition to sustain core data resources. And that activity from HFSP has been published both in the Nature as a small commentary and then as a full preprint in bioRxiv, but it draws very heavily on this ELIXIR concept of indicators that take a broad view. So I think this is something that we can learn from as a community when it comes to sustainability. It's not enough to have scientific excellence. You need to focus on the whole service package and engage with funders around that and talk about the long-term impact. So that's on the data side. The other part of FAIR is, of course, the interoperability. So how do you provide the service stack that allow you to use standards over a long term? We heard yesterday Ibrahim talked about the OLS, the ontology lookup service, and some of the tools that they built into the imperial offerings. And within ELIXIR, we've taken quite a broad view within what we call the interoperability platform to look at sort of the fundamental services such as ontology and identifier services, but you also need things like integrating services. So how do you interface with workflow systems, which is actually where most of the work happens. And then you have to work on the data set level with data set descriptions, at the content level with data record profiles and recommendations for those. And then we also try to work at the interface level, and the common workflow language is turning out to be something that is really catching on with many of our nodes and technical services, because it's easy to embed in things like Docker containers and other sort of high-level workflow management systems. So just an example of we're starting to build up what we think about a service stack and service framework. So these are tools that are being committed to and maintained long term from our nodes, so things like identifier.org, the biosharing standards registry, which I think Etrix is very familiar with, ontology lookup service, ISA tools, but also things like the common workflow language and Swagger type API descriptions. And one thing that that has come up the last year and we're very keen on is this idea of bioschema. So I thought I would just spend a few words on this. And so if you go to a web page, you see that many web pages and Google and the large search engines such as Google and Yahoo and Bing all support this. You can embed rich snippets through a standard called schema.org into web pages. So this is what makes, if you Google for apple pie, Google knows how long time it takes to make an apple pie, how many calories there are in an apple pie, and a lot of these things. And the reason for that is that the web pages with the recipes have embedded those sort of markups as rich snippets with schema.org. And so the same can of course be used in the life sciences. So we have developed what we call bioschemas, which really is a minimal standard for tagging up a resource. And so it is really at this end of the scale, the very opposite end of things like Sparkle. So it's very minimal, it's a few tags, and they're easily injected into web pages because everyone has a web page. So the idea is to really keep the path to adoption very, very low, and if people say, but couldn't we also describe X? You say, yes, of course you can describe X, but we'd like to keep it. So really not reinvent all of these complicated markup systems. And so this has been quite popular. So we have sort of positioned this at a very high reach, but very, very shallow. And you contrast that with standards such as DataMed, and that's coming out of NIH, which are very, very deep and very comprehensive, but as far they do take quite a bit of effort of encoding. And we'd like to support all of these standards in ELIXIR, but we'd like to get broad adoption, and so this supports the findability, if you so want, this supports the interoperability. And we have some early adopters. One really interesting early adopter is the Omics Discovery Index, which is run at EBI, but it's part of the PD2K Omics initiative, where they've started to use bioschemas to tag data sets. That is now being progressed, so there is actually a meeting next week to lock down the minimal information standard, and there is about 15 repositories that in a hackathon then are planning to start to encode repository information via schema.org, which should make it essentially Googleable. So you should be able to find this in Google. We've had quite a bit of interest from Google, so Dan Brickley from the London office has been coming to many of our meetings, and he's even blogged about it, which we're quite happy with. So, and I think that the key word there is that in the federated world, findability of resources really are essential. One example, and this nicely leads into beacons, because we are encoding beacons with schema.org, is really this data discovery services. So this, again, is the very minimal information you could put onto a cohort, is that really ask the question, do you have information about the allele C at this position on this chromosome? And then yes, no. And that's all you require. So it's a very, very simple data discovery service that, if the answer is yes, you will start to move on and have more advanced conversations with the cohort owner. So again, it's a very shallow path to adoption and increasing findability in a very federated landscape. Eventually, we would like things to be rich and incorporated in much richer catalogs, but we'd like to make sure there is an on-ramp to that utopia where we have deep catalogs of everything. And this, again, has been quite popular, and so we've lit beacons over the last 6 months in a number of countries with national cohorts. Some of these are completely open to the public. Most of them actually are controlled access, and the reason for that is that with a clever combination of allele queries, you can actually find out if an individual sits in a cohort. Now, if that's a national French cohort, that's not very sensitive, because someone whose genome you own, you would know that they are French. But if it's a cohort on, say, schizophrenia or depression or something like that, it's actually quite sensitive. And so we'd like to incorporate this into an authentication and authorization infrastructure, which is the current ongoing work. So that brings me to one of our flagship services, which is what we call the ELIXIR AI. You saw one example with the ARIA system, but essentially we'd like to support federated login of institutional IDs across Europe. This is now in production for a couple of months, and so we have about 300 identity providers. Not that many identities spawned yet, with 16 services, but really we think this is now mature enough for starting to scale up. And the key part here, which is the focus of this year, is really to link this to mutual recognition schemes where federated login can be used to access sensitive data. And the Nordic region have a large project with about 15 people over 3 years to tie together all of their secure access clouds on the basis of this. So that sits sort of in our sort of core compute services with the identify the user, data transfer systems, where we have now heartbeat systems between some of the major compute centers, where we know that we can benchmark compute transfer between the systems to the national users, and then spawning clouds on top of that. So armed with all of that, we think we can move into a more federated future, and one of our examples is the local EGA. The European Phenome Archive is one of our flagships. It's co-developed between CRG here in Barcelona, down at the lovely center at the beach, and EBI in Hingston. But not all sensitive data sets, genomic data sets or translational data sets, can be submitted to a global archive. And so if you can't give your data a passport, we have established what we call the local EGA, where the data actually sits out in our national nodes, but we submit metadata into EGA so you can do dataset discovery at the central. So this comes at a slightly higher price than the beacons. It's more complicated to implement, but of course it's a much richer data set. So you can see how we're moving sort of through an on-ramp of getting as much data as possible discovered. We like to do this through API, and the reason why I put this up is I think this is one of the ways to sustainability, is to provide very standard-based APIs that can be implemented and funded through local initiatives. And if then they are widely adopted, you have an inherently much more robust and sustainable system than if you try to engineer large transnational software systems. And so we have this vision of a standards-based, API-driven and federated future, but actually we're not a million miles away from this. So we have some of these components now, such as AI and metadata moving into production. The data transfer network is in place, and we do have the first release of the submission API. It was released by CRG here in Barcelona a couple of weeks ago. So this is actually something we're incredibly proud of. It's the first sort of Hello World implementation. It's not very interesting, you can watch it on YouTube, but actually what it is that it's a researcher in Finland who logs into a central Finnish cloud infrastructure using his university ID. Then he uses the same university ID to apply for access for a data set in the EGA, which is deposited by a researcher somewhere else in Europe. The Data Access Committee grants him access, and because he's using his institutional ID, they know that he is from the University of Turku. And once he has access, he can mount that dataset through a secure streaming interface onto a local cloud environment where the data is sandboxed, he can access and do something interesting with it. It's the first demonstrator, it's certainly not in production, but actually we are now at the stage where over the next couple of years, these standard technologies can be launched in a number of European compute centers. And I think that is a very interesting and very standard, very sort of robust future. So in the last couple of minutes, I just want to mention one more thing, which is how do we interact across the infrastructures. And so we saw 3 examples today. We have a project called Corebell, which brings us together, where we're looking at really how we can work together as organizations and drive things like shared data services, shared LC access, and shared training services. We've done that through an open call. We opened this before Christmas. We now actually have the shortlisted projects in flight. And really what we can see is how you can have sort of innovation tracks or development tracks where you access services from a number of different infrastructures in a single project. So, just to wrap up, because I can see time is running, I wanted to finish with a slide about, so how do we then access ELIXIR as a user or as a project in Europe? And the primary way of accessing ELIXIR is that you shouldn't even notice that we exist. And the reason for that is that we really are about strengthening these national nodes. And so if you are a researcher in Luxembourg, then you should work with Reinhardt as ELIXIR Luxembourg at a local level, and actually you should, as a Luxembourg researcher, you will be able to draw on all of these tools because they are available at the national level. So a good example is the ELIXIR AI, which is then based on the federated identity, and all the complicated business of mutual recognition and so on would be handled by the infrastructure and this coalition of national nodes. I think the other way you would work with us, you would see as a steward of international standards, where we're trying to drive standards of metadata management, so these collaborative interfaces across Europe, and really have a standard-based future. But the last way we do like to engage, and we do this in some of IMI projects, is where we brought together a service bundle in international consortia. We have a couple of examples. There's an IMI project led by Ferran, which is coming online very shortly, where we have drawn together a number of ELIXIR services into one sort of service package that would try to help and provide a platform for that project. But as I said, I think the main way of accessing ELIXIR is really through the standards that we implement at the national level through our national nodes.
Hi, I was wondering, in the concept of ELIXIR, I understand that it's distributed across the different nodes in the countries, as you explained. Is there a policy in ELIXIR for how then the nodes distribute resources in different institutes, or is that left up to the national nodes? And the reason I'm asking is that, it's the fine slicing can go infinite at some point. And if you over-distribute the resources, it becomes inefficient. If you centralize totally, it becomes inefficient. So how do you imagine defining that balance in the European level?
That's a really good question. And I guess the answer is it's always it depends. But so there are there's very few things that we mandate the national nodes to do, but there are some things, and so ELIXIR has a board which is composed of national funders, and so that we can bring a policy to the board, and that makes it mandatory for anyone who's signed a contract on our inside infrastructures to follow that policy. There's very few things we do that with. One is ELIXIR compliance and so on, but beyond that, I think the real answer is that we, for most of these things, we leave that up to the national node, and the reason for that is that the national nodes are very, very different in their maturity. So some of them, like SIB, has operated as a single entity for almost 20 years. They have a high degree of centralization and central services, which they've built up over the years, and they find that very effective and very sort of a good way of operating this risk environment. Other countries where the nodes are much more immature, they will have a much more federated and loose network, and they're not quite there yet where they can really mandate things on the national level. And we try to cater and support both of these scenarios. So I think that it really depends, and also the research context is very different in the different nodes. With some of them are really partnering into major national program. Again, SIB is the driver behind their personalized medicine. In Luxembourg, which is a very small node, but it's deeply embedded in some of the big national research projects. In other countries, they have a much more competitive sort of access mode where the different institutes are competing in a much more competitive research landscape, which isn't by design, it's just the way that the science works in that country. We want to drive and support all of these different cases.